Okay, guys, so we've talked about how important constant and linear relationships are on our STAR test, so I wanted to do a quick review with you. And it does start with graphing points on a coordinate plane. So a coordinate plane has the x and the y axis. So the x here is your horizontal line. And you can think about that as, say, a number line. So the origin, 0, 0, is the center, and that's where the y-axis goes up and down. So if you go to the left, you're going negative, and if you go to the right, your x value is positive. And then you have the y-axis, and you can remember that the y-axis goes up and down because a y goes up and down. So, and what you can kind of think of with the y-axis, and it's like the x is the surface of the water. And if you're above the water, it's positive. If you're below the water, it's negative. So if you graph a coordinate, let's say that we wanted to graph coordinate 4, 5. So a coordinate is written as x, comma, y. So you're going to start at the origin, which is 0, 0, where the two axes cross, and you're going to start here at the origin. And if it's a positive 4, so x is first, so you're either going to go right or left. So if it's positive, you go to the right. So 1, 2, 3, 4. And then the y is second, and you're either going to go up or down. So up if it's positive, down if it's negative. So since it's a positive 5, I'm going to go up 5. 1, 2, 3, 4, 5. So this here is the point 4, comma, 5. What if I was graphing the point -3, 2? So x is first, so -3 means I'm going to go from my origin and I'm going to go to the left, 3, 1, 2, 3, and then up 2. So that is -3, 2. And then let's do another. Let's say we have 6, -3. So 6 is positive, so I'm going to go the right 1, 2, 3, 4, 5, 6, and then down 3 because it's -3. 1, 2, 3. And then let's do one last one of -4, -7. So -4, again, we always start at the origin. I'm going to go the left 4, 1, 2, 3, 4, and then -7 means I'm going under the water. 1, 2, 3, 4, 5, 6, 7. So it's important that you know how to, let me write these in for you, 6, -3, how to graph points and how to use points to create a table. So we'll look at that in a minute. Okay, so first is constant of proportionality. So constant of proportionality, constant describes how one quantity changes in relationship to another quantity. So proportional relationships form a straight line that passes through the origin, which we talked about is 0, 0. 0 for x and 0 for y. So constant k equals y over x, and you will see this on your formula chart as constant of proportionality, like the title here, k equals y over x, and the equation is y equals kx. So let me give you a couple examples of a line that represents constant of proportionality. So we could have one that goes like this. We could have one that goes like this. I'm doing the best that I can with straight, but let's just pretend they're all straight. This, any of these that are a straight line and go through the origin would be representative of a constant relationship. So let's practice a problem finding constant. It says the table below shows the prices for a classified ad in a local newspaper. Using the data from the table, what is the price for one line? So we want to find the price of one line. So we're finding the constant, k equals y over x. So you can choose any of these. to start with, and you have to make sure they all match. So 15 divided by 2. So if you need to do your math, you can. Divide by 2. 2 times 7 is 14. 1, put a decimal, bring down a 0.5. So it equals 7.5. And to represent a constant relationship, you would have to do that with each. So 30 divided by 4, I can simplify that to 15 over 2. So that constant would be the same as with the next two relationships. So my constant is 750, so one line equals 750, because this can be reduced to 750 over 1. So what about from a table? A table, a local shipping company charges 65 cents an ounce for shipping packages within the state of Texas. Which table represents the same relationship between the weight of the package and the price? So we need to think first, the weight of the package, is that our X or our Y? Well, it's independent, right? Because the price is dependent. It's depending on the weight. So X is Y, or X is weight, sorry, Y is price. So K equals Y over X. So we're thinking price over weight. And you'll know that as well because in tables, X is always written first and then Y. So if it's saying that it's 650 an ounce, that means in 1 ounce. So that's our constant. So 65 cents in 1 ounce. So let's go through the tables. This says 2 ounces is 65 cents. That's wrong. 2 ounces is $1.50, maybe. Okay, so we can off the bat eliminate 1. So if 65 cents over 1, let's say what is 65 cents over 1 equals what over 2? So I need to double 65 cents. So 0.65 times 2. 2 times 5 is 10, 12, 13, 2 numbers to the right of the decimal, so $1.30 is 2. So let's see, here it's $1.50, so no. So I'm down to the bottom 2. So if I double 2 ounces to get to 4, then I would double $1.30 and get to $2.60. So this one is correct, but pay attention because not always, the graph will not always go at the same rate. This may be 2 ounces, 5 ounces, 7 ounces, 8 ounces, so pay attention to that.